All right, Algebra 2, we're going to go ahead and finish off Unit 3.1. So we started with graphing in standard form and vertex form, and we saw all the different things that you have to find to graph a quadratic. And so now we're going to look at what's called the average rate of change. So we're going to use this average rate of change throughout the year in lots of different kinds of functions. So the average rate of change over a specified interval gives us a sense of whether the function values are mostly increasing or decreasing. All right, and so the formula to find the average rate of change is very similar to the slope. In fact, they get this formula from the slope. All right, so the slope formula, again, y2 minus y1 over x2 minus x1. All right, so let's look at how this works. The average rate of change of a function from x equals a to x equals b. All right, and so we're trying to find out how are they changing? How are the values changing? And we want that average. All right, so you know, sometimes if we were looking, so let's say we have some point A and some value B, and you know, it could go up, it could come down, you know, something like that. And we want to know how are the values changing on average as we go up and down and up and down. And so we're looking at that line, and that's the slope. All right, and so that will give us an average of how the values are increasing and decreasing over a specific interval from A to B. So this formula, f of b minus f of a over b minus a, again, is from the slope. All right, so let's do this first example. Using the graph, find the average rate of change over the interval from x equals -4 to x equals 1. So sometimes they'll say it like this, x equals, you know, a specific number to another number, that's the interval. And then sometimes they'll do it in brackets, so they're saying the same thing, x equals from -4 to +1. So if we look at this graph, this quadratic, we can see these 2 points on the graph they highlighted for us. And so if they didn't do that, you would want to highlight them. So from x equals -4, and so you can see on the graph, there's a point here that uses -4 for x, all right? And so that's the point -4, +1. And then there's another point that uses +1 for the x coordinate, all right? And that's right there. And so that point is 1, looks like 6. And so what we're trying to do is find how are the values on average changing as we go from x equals -4 to x equals 1. All right, and so one way that we can do this is use our slope formula. All right, and so remember it's y2 minus y1 over x2 minus x1. All right, and so we could do this as 6 minus 1 over 1 minus -4. All right, so I put the y's on top, x is on the bottom. All right, and then if I simplify this, 6 minus 1 is 5, and 1 plus 4 is 5, and so that slope is 1. All right, and now another way that we can do this is kind of think of how rise over run works. Now we can do this on a graph only if we're careful with how the units are for the x-axis and the y-axis. So you have to be careful with that if you're going to use rise over run. But we can do that on this problem because we can see the x's are changing by 1, and the y values on the y-axis are only changing by 1 also. So if we count up, up a little here. Okay, so that's 1, 2, 3, 4, 5 up. Okay, so rising 5, and then going to the right, so that's our run, 1, 2, 3, 4, 5 also, and then rise over run is 5 over 5, and so that's also 1. All right, so that's on average how they're changing. So even though, you know, if we were going from left to right, you know, this is going down and then it turns around and comes back up again, on average the slope is +1. All right, so let's do example 2. So now we're going to use an XY table. So it says, using the table, find the average rate of change over the following intervals. All right, so from x equals 0 to x equals 3. So on a table, it's pretty easy because all you have to do is kind of highlight when x is 0. Okay, so here it is. Here's the ordered pair. And then when x is 3, all right, so here's the ordered pair. And then you just use your slope formula. So the y's go on the bottom, or on top, and the x's go on the bottom. All right, so this would be 24 minus 3. Okay, these are the y's, 24 and 3, over the x's, 3 minus 0. All right, and then we'd simplify that. That's 21 over 3, and then that would simplify to 7. All right, so let's do each of these. For example 3, again, they give us this table. We're going to find the average rate of change from x equals 0 to x equals 2 first. So x equals 0, there's the ordered pair, and then x equals 2, there's the ordered pair. And so we'll do negative 3 minus 5 over 2 minus 0. So that's negative 8 over 2, and that simplifies to negative 4. So the average rate of change from x equals 0 to x equals 2 is negative 4. All right, so let's do B. So from x equals 1 to x equals 4. All right, so here's the ordered pair for x equals 1, and then x equals 3. So that's going to be negative 7 minus 1 over 3 minus 1. So that's negative 8 over 2, and that's negative 4 again. All right, C, x equals 3 to x equals 4. So negative 11 minus negative 7 over 4 minus 1. Sorry, 4 minus 3. So double negative, so that's negative 4 over 1, which is negative 4. So in this example with this XY table, it really doesn't matter which interval we pick, and that's because since all the average rate of change values or slope is the same, this XY table actually is a line. And when you look at the average rate of change for a linear function, it's really just the slope, and the slope is negative 4. And it doesn't matter which interval you use, the slope's going to be the same. All right, and then example 4. So this is just review of evaluating a function. And so we have to know how to do this so we can do the next example. All right, so we want to find f of 3, f of negative 2, and f of 1 given the function f of x equals 4x squared minus 5. So the number in the parentheses is the x value. All right, and so you're just going to substitute that number they give you in for all the x's, and then you just use order of operations to simplify. All right, so finding f of 3 for this function, we have 4 times positive 3 squared, and then minus 5. All right, if you need to use calculators, use calculators. Order of operations, you have to do exponents before multiplication. So 3 squared is 9, 9 times 4 is 36, minus 5, and so that's going to be 31. So what this says is f of 3 equals 31. 3 is the x value, and 31 is the y value. All right, so again, this is like the ordered pair. If this function f of x equals 4x squared minus 5 was graphed, the point 3 comma 31 would be somewhere on the graph. All right, so the graph would be passing through this point 3, 31. All right, let's find f of negative 2. So again, we're plugging negative 2 in for x. So that's 4 times negative 2 squared minus 5. So negative 2 squared is 4. 4 times 4 is 16 minus 5. And so that's 11. So again, x is -2, y is +11. And there's this point -2, 11 that the graph passes through. All right, f of 1. All right, so that's 4 times 1 squared minus 5. So 1 squared is 1. 1 times 4 is 4. 4 minus 5 is -1. All right, so when x is 1, y is -1. All right, and then this next example, using a function to find the average rate of change. Again, we're going to use this formula, f of b minus f of a over b minus a. All right, so here's our function. They give us f of x equals -x squared plus 2x minus 1. And we want to find the average rate of change over the interval -4, 2. All right, so the first thing you're going to do is find what f of 2 is and f of -4. All right, so just like we did with the above examples. You're going to substitute those numbers in for x and then evaluate it to simplify it. All right, so let's go ahead and find what f of 2 is. All right, so that's -2 squared plus 2 times 2 minus 1. All right, so that's 2 squared is 4. 4 times -1 is -4. 2 times 2 is +4 minus 1. All right, -4 plus 4 is 0. 0 minus 1 is -1. All right, so f of 2 is -1. Now we're going to find f of -4. Okay, again, we'll do the same thing. Substitute -4 in for all the x's. So -4 squared plus 2 times -4 minus 1. Okay, order of operations. -4 squared is 16. 16 times -1 is -16. 2 times -4 is -8, and then minus 1. -16 minus 8 is -24. -24 minus 1 is -25. Okay, so we found our two functions values, f of 2 and f of -4. All right, now the second step is to substitute all these numbers into our formula. Okay, f of b minus f of a over b minus a. So we already found what f of 2 is, okay, and that's -1. Minus, and then f of -4 we found was -25. Okay, and all that's going to be divided by the b minus a, okay, and then 2 minus -4. All right, so again, 2 minus -4. And we can simplify this. We have a double negative on top and the bottom. So -1 plus 25 is 24. And then 2 plus 4 is 6. And 24 divided by 6 can simplify to 4. So the average rate of change over the interval -4 to 2 is +4. All right. Again, the interval from -4 to 2, -4 is your A value and 2 is your B value. And that's what you're substituting into the formula. All right, and then let's go ahead and do this next example. F of x equals 2x squared plus 4x plus 1. And we're using the interval -3 to 3. All right, so again, -3 will be our A value. +3 will be the B value. So it's kind of in order, alphabetical. All right, so let's first find f of 3. So 2 times 3 squared plus 4 times 3 plus 1. So 3 squared is 9. 9 times 2 is 18. 4 times 3 is plus 12, plus 1. 18 plus 12 is 30, plus 1 is 31. All right, now let's find f of -3. So 2 times -3 squared plus 4 times -3 plus 1. -3 squared is 9. 9 times 2 is 18. 4 times negative 3 is minus 12 plus 1. 18 minus 12 is 6. 6 plus 1 is 7. All right. So again, we're plugging all these numbers into our formula. Again, this would be f of 3 minus f of negative 3. Okay, again, f of b minus f of a over the b value minus the a value. Okay, so again, we have that double negative. All right, so f of 3 we already found is 31 minus f of negative 3 we found was 7 over 3 minus negative 3. We can simplify this. 31 minus 7 is 24. 3 plus 3 is 6. 24 divided by 6 is 4. All right, it's just a coincidence. We got the same value. It's not always the same. All right, and then this last thing I want to do is just review some Algebra 1 concepts, because these concepts are going to come in a lot in this Unit 3 as we progress through the lessons. And so I just want to kind of go back and review some of these concepts. All right, so when we want to add like terms, remember like terms are terms that have the same variable and same exponent. And if you have that, then you can add the coefficients, which are the numbers in front of the variables. All right, so for example, 2x plus 3x, that's just 5x. Okay, so it's like 2 apples plus 3 apples, 5 apples. All right, x plus x, okay, same thing. That's just 2x. Okay, again, the coefficients in front are 1, and so 1 plus 1 is 2. C, again, we want to find the like terms. All right, and so we can combine 4x squared and negative 6x squared together. So that's negative 2x squared. And then we can combine 2x plus 1x, and that's 3x, so plus 3x. All right, multiplying terms. So when we're multiplying with variables, they have to be the same variable. So if you're multiplying x and y together, that's just xy. There's nothing else you can do. But when they're the same variables, what you're going to do is multiply the coefficients, but add the exponents. Okay, so 2x times 3x, we can multiply the 2 and the 3, that gives us the 6. And then the x times x, we want to recognize that there's exponents on each of those x's, and you're adding those exponents. Okay, so when we multiply variables, we want to remember to add exponents. So that's 6x squared, because 1 plus 1 is 2. All right, again, b, x times x. The coefficients in front of the x's are 1, and so 1 times 1 is 1, and then x times x, again, we're going to add the exponents, x squared. All right, and then c, we're multiplying, so 4 times 2 is 8. Then x squared times x, again, there's an exponent 1, and so that's x to the third. So we couldn't add 4x squared and 2x together, but we can multiply them together. Okay. All right, and then radicals. So radicals are going to come up in the next lesson. We're going to be talking about what are called imaginary numbers. And so we're going to be looking at radicals to do that. So we have to be able to simplify a radical first. All right, so let's go ahead and simplify each of these radicals. So square root of 49. Okay, you're just trying to find a number that multiplies by itself that equals that number. 49 is perfect, and you can break this down as 7 times 7. And because you got a pair of 7s, the answer is 7. All right, so square root of 49 is 7. Now, 24 is not a perfect square, because if you put square root of 24 in the calculator, you're going to get a decimal. So what we want to do is break this down into, you can either break it down into a perfect square times another number, or you can just use a prime factorization, a factor tree, and break it down as far as you can go, and then find a pair of the same numbers. Right? So that's what I'll do on 24. So you can start it out any way, any two numbers multiplied to 24. So you could use 4 times 6, 8 times 3, 2 times 12. It doesn't matter how you start it. Right? And then you're just going to keep breaking these numbers down as far as you can go. 4 I can break down to 2 times 2. 6 I can break down to 2 times 3. And I can't break those numbers down any further. So now what you're looking for are a pair of numbers, a pair of the same numbers. So here's a pair of 2's. Right? Now that 2 is going to come outside. Okay, because there's a pair, just like we did a pair of 7's, the 7 gets pulled out. When we have a pair of 2's, okay, the 2 gets pulled out. Now I have this 2 and 3 still left over. Now, since they're not paired up, they're not the same numbers, all I can do is multiply those back together and keep them under the radical. All right? And so radical 24 will simplify to 2 radical 6. All right, so let's try 120. Again, you just got to find 2 numbers that multiply it to 120. There's a lot of numbers. You just got to find 2 of them. You can do 12 times 10, 3 times 40. So there's a lot. 6 times 20. All right, so I'll do 12 times 10. That's 120. 12 I can break down to 4 times 3. 4 is 2 times 2. 3 doesn't break down. 10 I can break down to 2 times 5. All right, so again, this is all multiplication here. And so now I need to find a pair of the same numbers. So again, here's a pair of 2's. So I know I'm pulling a 2 out. There's a 3, there's a 2, and there's a 5 left over. And none of those are the same. So all I have is a pair of 2's that I can pull out. So the 2's coming out. And then I'm just going to multiply what's left over. So 3 times 2 is 6, 6 times 5 is 30. And that'll stay inside the radical. All right, so 2 radical 30. All right, so multiplying radicals, similar to what we did with multiplying terms. With radicals, you can kind of see the formula. We multiply what's outside together. That's like the coefficients. And then we multiply the inside terms together. All right, so radical 6 times radical 6, that's going to be radical 36. And then square root of 36 can simplify. That's exactly 6, and the reason is because you can break it down to 6 times 6, and that's a perfect pair, okay, a pair of 6's. All right, B, 4 root 5 times 2 root 7. Again, we can multiply the outside numbers together, that's 8, and then multiply the inside numbers together, 5 times 7, that's 35. All right, again, you want to simplify your radicals if you can, so we can break 35 down. 5 times 7. Now I can't break either of those numbers down any further, and I don't have a pair of the same numbers. So that means that 8 radical 35 is not going to simplify any further. All right, C, same thing. We can multiply outside with outside, inside with inside. Negative 2 times 3 is negative 6. And then 5 times 8 is radical 40. Again, we want to try to simplify this, so I can break it down. 40, I could do 4 times 10, 5 times 8. 4, here's 2 times 2, so there's a pair. 10, you can only go 2 times 5, and I don't have any other pairs. All right, so this pair of 2's is coming out. Now, because the 2's coming out, it has to get multiplied by anything that's already out there, which is negative 6. So you're going to multiply 2 times negative 6, so that's negative 12. And then the 2 and the 5 are not the same, so I multiply those back together and keep them under the radical. All right, so that's negative 12 radical 10. So negative 12 times radical 10. All right, and then our last one, D, this is dividing with radicals. So I'm sure you've heard of rationalizing the denominator. And so all that means is we're trying to get rid of the radical off the bottom, off the denominator. You can have radicals in the numerator. We just typically try to get rid of the radical off the bottom. And so to do that, radical 7 over radical 3, we're trying to get rid of the radical 3 on the bottom. So to do that, we can multiply top and bottom by radical 3. All right, again, with multiplication, we just multiply across. Outside numbers with outside, inside with inside. So radical 7 times radical 3, since they're both inside the radical, we can just multiply them together and keep them inside, so that's radical 21. On the bottom, radical 3 times radical 3, that's radical 9. But radical 9 is perfect, and you can simplify that. And so this is root 21 over 3. Now we can't simplify 3 and 21 and make it root 7, and that's because the 21's under a radical where the 3 is not anymore. All right, and so that's as far as you can go with that. And we got rid of the radical off the bottom, and that means we rationalize the denominator. All right, and that is it.